So at the point in the installation now where we need to connect these new 25mm squared meter tails and 16mm earthing conductor from a consumer unit to the incoming supply, Joe. What does that really mean?
So basically we're going to be splitting the tails, and of course we know that we're going to be fitting these fixed connector blocks into the back of here, popularly known as Henley blocks, and then we're going to reposition some of the tails while taking a supply out to our new consumer unit. Now we've chosen to split the tails for this installation for a number of reasons, which include that it's quite tricky for us to source the correct MCB to go into the spare way of our consumer unit. It gives us an opportunity to add some surge protection into the installation, and also it's important that we demonstrate how this is done so that we can show how to get the current transformer into the correct position on the incoming meter tails.
Before we do that, we're going to have to safely isolate the supply. We're in a wonderful position in this install that there is a switch built into the meter. We're going to isolate that switch, prove it's dead, and then we're going to make these connections. I think, Joe, if we bring the camera in super close, we can give people a feel for the next stage of the install.
Let's get cracking.
So around at the mains end, and we're in the process of prepping the actual connections for the new consumer unit with the tails here. So we've got our line, neutral and protective conductor. We've got our connections ready and mounted, and we're at the stage now where we need to isolate the meter, going to disconnect the tails. These tails are going to be moved into the blocks, and a new set of tails will be swung round into the blocks. What's our issue here, Joe, with making sure our tail length is correct?
What we've got to think about really carefully here is this is the point where we're going to be mounting our CT, our current transformer, that speaks to the ZAPI and allows it to monitor and control the current flow to your electric vehicle when it's charging. So we need to make sure that we leave enough space on the right cables in order to put our current transformer into the correct position.
Okay, and we'll get to that in this part of the presentation. I think first of all, we're going to actually take this cover off. We'll be very careful here. Take this cover off. We're going to isolate it using the switch, and then we're going to prove it's dead, and then we can start looking at these connections and working out which one that CT meter is going to go on.
Okay, so the first thing we're going to do is we're going to remove this cover here. I must have undone hundreds of these in my time. So just undo this little front cover, and that allows us to access the isolator switch. And it also should have a little plastic cover over the live terminals there, which means that we can't get a shock from that. So we're ready to turn this off. We'll remove the little plastic protective cover that's in place there, and then we can carry out the safe isolation procedure. Yeah,
just one word of warning. Remember, because we're operating this switch, that we've de-energized the circuits within the actual installation, so we're not turning this off on full load current. That wouldn't be good practice.
So without further ado, we'll turn the power off. So there we go, that's now isolated. So we're in a position now where we can remove the little plastic protective piece. So I'm just going to get in there with the pliers and whip that out of there. And Gary, if you'd like to now just perform the safe isolation procedure.
Okay, so as always, proving unit in this case and voltage indicator. I'm going to prove that these are working correctly before we start. Okay, yeah, so we're fine with that. And then we're in, and just as always, good practice to go on the least dangerous conductor first. So onto my neutral, onto my line conductor, no voltage present, off my line conductor, off my neutral. I'm going to test now between my earthing conductor down here and my neutral, off my neutral, off my earthing conductor, and then finally onto my earthing conductor, onto my line conductor, off my line conductor and off my earthing conductor. And at no stage there was this reading a voltage, so therefore, Joe, was safely isolated just to prove my test equipment before finishing. Just put it back into my proving unit. Test is all good, so I'm happy we've safely isolated that one, Joe.
So we can start disconnecting these conductors and we can start doing the changeover.
Okay then, so this is our line, neutral and earthing conductor for our new consumer that we installed within the installation. We'll look at that again later on. These are a little bit fiddly here, Joe, in order to poke these in. So we want to push that down for us. Okay, I think we can connect those up then.
Absolutely, so we'll get that tightened up in there. And that's our line conductor connected out to our new consumer unit. And then we're going to put the neutral in.
Just hold that for us, just pop that through again. A little fiddlier than it should be. There we go.
That's in place, so we'll crank that up. And that's now tight.
We'll take our earthing conductor, and again, if you hold that for me, just in we go, yeah.
This reminds me of an old joke. How many electricians does it take to change a light bulb? There we go.
Okay, so that's in. So we've now got to take this set out and move them across and then produce a new set into here.
Okay then guys, so we've got our tails transferred over now. So we've got our new tails going off to our new consumer unit here. We've got our existing tails going off to our existing consumer unit on this side, and all that remains now is what?
We're going to actually put the neutral and line conductor into these blocks to energize them, and it's important that we leave enough on the line conductor in order that we can put our CT onto it. So it's no point having a really tiny one or a tight bend and find that you can't actually put on the CT over the top of it. So it's important that we do that next.
Absolutely. So I think we grab the CT, have a little look at that, see where it's going to go, and then we'll talk about getting these tails installed. So here we've got our current transformer. So this is our CT that we're going to be using to monitor the current that's flowing into the installation, and we need to have this so that it is wrapped around essentially the main conductor, the line conductor that feeds the property. So this is going to be able to monitor all of the current that's flowing into the building, not just the current flowing into the existing installation, not just the current flowing into our new installation, but the whole current. So it must go on the conductor that goes from the live terminal in the meter to your first Henley block. So let's get these tails installed then, Gary.
So let's pop the neutral into the kilowatt hour meter.
Our line conductor stuck in there as well. It's easy when it's new tails, isn't it? Yeah. I had the difficult ones where the tails were all malformed and all over the place.
Go down.
That's it, that's all the way in. Connection. Okay, Gary, so we have now split the tails successfully. We've got our new supply going out to the Henley blocks. We've got our new tails going out to the new consumer unit, existing tails going out to the existing consumer unit, and that's really good because we're now in a position where we can think about fitting the clamp meter in the correct position. Okay then, Gary, so we've now got a jumble of cables inside here. We've got a lot of tails going on. So can you just explain to me what's happened inside here?
Yeah, so we've split the tails from the kilowatt hour meter, taking our supply into our Henley blocks up here, and we've got the outgoing line and neutral to our new consumer unit, and then we've got our original neutral and line for the consumer unit within the dwelling that was already there. And obviously we've got the supply tails coming in with both our neutral and line here. And it's quite important, Joe, that we left this line conductor from the kilowatt hour meter of a reasonable length. What's the thinking behind that?
Well, we've installed that deliberately at the very front of all of the other tails because we know these can get a little bit stiff when there's a lot of them in place, and it can get a little bit tricky to access them. But this is the one that we really need to access because that is where we're going to install our CT, our current transformer. Now this is an absolutely critical piece of kit because it speaks to the Zappi and it tells the Zappi how much current is flowing into the installation, and the Zappi then very cleverly controls how much current is flowing into the car charging system.
And that's really important because we don't want to overload the fuse here. The incoming cutout fuse doesn't want to be taken more than its rated value, and this CT will help us do that, Joe.
Absolutely. So it'll monitor the current and make sure that it stays at acceptable levels from the car charging point of view. Now you might look at this and think, we've forgotten to install that. We've got to get the cable through that little hole. Well, you're absolutely right, we do. However, it very cleverly hinges open, which means that we can just connect that around the conductor. But there's one other thing, and this is absolutely critical at this stage, Gary. What do we need to do here?
We need to make sure its direction is correct. In other words, we're going to measure the current coming into the installation, and we've handily got an arrow pointing that way, and that's the way in which we need to clip it on in order that we can get the current coming into the installation.
Absolutely. So you can see there's an arrow on the bottom of it, and we want to get that, as you say, around the line conductor into the installation. So that is now going to measure the current that's flowing into there, and we can wire this across to our Zappi charger as well. It's also worth noting at this stage that the current transformer has been designed so that it can be cable tied onto the tail that you've got it connected to. So we'll demonstrate how to do that towards the end of the video when we've got this in its final connection.
So we've popped inside. Benefit to Joe, you've noticed in the videos he's been wearing that t-shirt, and it's bitterly cold outside. Jacket helps me. So we're looking at the consumer unit itself that's been installed for the new Zappi 2 EV charging point. We saw outside how we split the tails. We've got a set of tails now feeding the main consumer unit, and a set of tails now feeding the actual new consumer unit for the Zappi 2. We look inside here, and I can see the new circuit, widened 6mm squared cable, twin and CPC, is actually fused at 32 amp and a Type B MCB. Is that acceptable, Joe?
Absolutely. The only reason we'd need to start thinking about RCD protection at this point was if we needed to protect the cable that is feeding the EV charging point. The Zappi has the RCD technology built in to protect the socket outlet and the car that's being charged and anyone who may be using that. But we don't need to protect the cable in this installation because we've installed it in such a way that it doesn't require RCD protection.
Okay.
Basically, we've surface clipped a bit of twin and CPC. If, however, we decided that we were going to protect our cable feeding the EV charging unit, maybe the cable's buried in the wall or something like that, and it doesn't have earth protective conductors around it, armouring and such, then what would we need to think about with the RCD protection for that cable, Gary?
Yeah, it comes now down to selectivity. If there was an earth fault and an RCD was installed here, we know there's RCD technology also in the Zappi 2, which one of those RCDs is going to operate, and therefore the selectivity issue comes up. For me personally, with no other circuits being in this consumer unit, I wouldn't be bothered if the RCD in here tripped or the one in the actual Zappi 2 was to operate, but you've got to consider selectivity. Also, you would need to consider this to be an A-type RCD as a minimum. We know the technology built within the Zappi unit will mean that no more than 6 milliamps of DC will appear in the line and neutral conductor, and therefore an A-type RCD at this end would also be handled that 6 milliamps current.
Okay then, Gary, so just one more thing worth mentioning at this stage. What have we got installed here?
Yeah, the customer decided that it would be good for them to have a surge device inserted. We're going to be plugging in potentially a £40,000 car full of electronic components. In the event of a surge in the installation, we wouldn't want that to be fed down to the car. There's loads of electronic components also within the Zappi 2 that would be protected by the surge device being inserted here. So they decided to have that device inserted. So we've wired our circuit, Joe, the 6mm squared cables here, our consumer unit's installed, we're ready to install our Zappi 2 EV charging point.
I know you're really excited about installing that, Gary, but before we do that, we've got to get RCT installed. We've got to get this wired in. So I think we need to just hold off doing that a second.
I think if we take this end here and I just poke it through here, Joe, we're off and fitting.
Again, great idea, but then we would have to shove this device, the actual CT itself, through the wall where the tails are into the meter cupboard. So you can imagine that that's going to cause some problems. Perhaps the equivalent of forgetting to install your buzz bar shield before you put the consumer unit lid on. How many times have we all done that? So where do you think would be better to start from?
I think we've got to take this, we've got to go back to where we've got the metering equipment, and we've got to poke that one through and install that before we can put the EV charging point on.
So as we said earlier on in the video, it's best practice to connect the current transformer onto the meter tail using cable ties. So these little tags here have been designed to accommodate a cable tie, and we very simply just pass that around the meter tail and then pull it tight into there, and you can see that that's going to hold that nice and firmly in place. We'll pop one on the other side as well, so I'll just pop that around there like so, get that started through the cable tie, and then we'll just tighten that up, and as it does so, you can see that holds that nice and firmly in place onto our meter tails, and then it's just a matter of snipping off the ends and that's installed. So let's just summarise the video that we've seen here today, Gary. So we started off by looking at how to split the tails down and how essential it is that we get the right conductors into the right places in as safe a fashion as possible. So when we're talking about safety, primarily when it comes to this, Gary, what do we want to think about?
We're talking about means of isolation. That may be local, so there may be, in our case, a switch to turn off the supply to the outgoing tails from the meter, or you may need to seek permission from the DNO to pull maybe the main cutout fuse, or to have a switch installed prior to connecting the new tails.
Absolutely, and of course, if we were to move away from the energy meter where the isolating switch is, we'd want to make sure that remained locked off so that nobody could turn that back on and become injured in any way. All of our equipment must conform with what, Gary?
Our testing equipment should conform to GS38 and all the requirements for that, and we should also, as shown in the video, prove our test equipment before and after using it.
Excellent, yeah, following very carefully all the safe isolation recommendations that have been published from various sources. As this work's progressing, it's very important to make sure that we leave room for our CT to be installed onto the cable. We don't want to bury the cable around the back of the other tails to make it very difficult to get the CT on. We want to think about where that's going to end up. And connected to that, we want to make sure that the CT is connected onto the right conductor. So which conductor are we talking here, Gary?
You're looking at the line conductor from the outgoing side of the meter. So we've got line and neutral coming in and then neutral and line going out. And it's important that you select the outgoing line conductor from the kilowatt hour meter that feeds into the Henley blocks, but not individually to a separate consumer unit or a separate consumer you've installed for the EV charging point.
And just further to that, it's really critical as well that we get the CT pointing in the right direction. So you look at the base of it, it's got an arrow on it, and that current should be pointing effectively into the installation away from the energy meter. So that's a critical point as well. We then moved on and looked at the consumer unit that we'd installed inside. There was no RCD protection on that consumer unit, Gary. Why is it a good idea perhaps to try and install your cable in such a way that RCD protection won't be required for the cable that you're installing?
Yeah, we're looking at selectivity. If we have two 30 milliamp RCDs, one in the consumer unit in which we've installed protecting the cable, and then one within the technology of the ZAPI 2, which is also the equivalent of a 30 milliamp RCD, in the event of an earth leakage, we can't guarantee which one of the two RCDs would operate and therefore have lack of selectivity. So that's something worth bearing in mind.
Absolutely. We also want to give serious consideration to surge protection. That's something that we'd need to have a conversation with the property owner if it's a domestic installation and see if it was something that they were interested in having. But really that is something that's going to become increasingly more important as time goes on. And you're not just thinking about protecting the car that you're plugging into the charging unit, you're also thinking about protecting the charging unit from those surges that can occur in the distribution system. And then finally, we saw the importance of making sure that we installed the CT from the mains connection. We want to make sure that if we're going to be installing that CT, that we start at the meter end so that we don't have to push that relatively large CT through any holes in walls and things like that. If you find yourself in a situation where you need to extend the cable, Gary, what's the recommendation? What type of cable would be suggested to use to extend the CT cable?
You're going to be using Cat5 cable, and they recommend you use a screwed connection to join those conductors together. Remembering you're only going to need to use one pair, so in other words, two conductors within a Cat5 cable to extend the CT meter cable in order to make sure it can reach the actual EV charging point itself.
Absolutely. Interesting point there about the screwed connections. So we wouldn't want to be using the lever type connections because some tests on this particular type of installation, a CT installation, have shown that they don't work quite as well as a screwed connection. So then you'd want to think about leaving that screwed connection somewhere where it's accessible so that you can get to that for inspection and testing. As an alternative to a screwed connection, you could also use a crimped connection. That would be perfectly acceptable. But whichever route you take, bear in mind that a good connection for your CT is absolutely critical. So it would be a good idea just to twist the wires together that you're joining before you screw them together or before you put the crimp in place. You may also find yourself in a situation where you're installing multiple CTs and you might want to extend that with the same Cat5 cable, but use just one pair per CT, so one twisted pair from the Cat5 cable per CT, and that helps to avoid any crosstalk or miscommunication between the currents being measured in various conductors. So all that remains in this video is to say thank you very much for watching.